Welcome guys, let's solve another LeetCode daily challenge. Add one row to tree. Given the root of a binary tree and two integers, val and depth, add the row of nodes with a value. Val at the given depths called depths. Note that the root node is at depth 1. Well, this is a very important point to consider. The adding rule is as follows. Given the integer depths, for each not null tree node car at the depths equal to depths minus 1, create three nodes with value equal to val and as car's left subtree root and right subtree root. Car's original left subtree should be the left subtree of the new left subtree root. Car's original right subtree should be the right subtree of the new right subtree root. If depth is equal to 1, that means there is no depth minus 1 at all. Then we create a tree node with value equal to val as the new root of the whole original tree, and the original tree is the new root's left subtree. And well, this is one of our base cases we need to consider this case. This challenge is pretty simple, and if you're familiar with tree traversal, this won't be any difficult at all. Let's consider the first example. Here, as it says, root starts at depth 1, and here depth is equal to 1. Depth is equal to 2, and the val is equal to 1 here. And it says that, let's build our new tree. We have our root equal to 4, the depth is 1. At the depth minus 1, it means at depth minus 1, it means we should start right after the root, and here the depth is equal to 2. Here it means we have to create two new nodes equal to val equal to 1 here. They should become the left and right subtrees of the original root, and it says that car's original left subtree should be the left subtree of the new left subtree root. It means we need to take the whole left subtree and append or make the left subtree of the new node. Let's do this. Let's add these nodes. 2, 3, 1, and this becomes the left subtree of the new left node, and we'll do the same thing for the right subtree of the original root or original node. And this becomes car's original right subtree should be the right subtree of the new right subtree root. It means this subtree will become the right subtree of the new root. Let's add them. 6, 5. Well, this is our new subtree, and we should return this root node as the answer for this challenge. And let's consider this base case. If let's say that we have the following tree, we have 4, 2, 3, and the depth is equal to 1. Since there is no depth minus 1 at all, we need to create a new node. Let's say the value is equal to 1, and the original tree becomes the left subtree of the new node. 4, 2, 3. This is the answer for this base case. As you can see, it's pretty simple. Speaking about time complexity will be O(n) because initially we don't know about the depth of this tree, and that's why we have to traverse the whole tree, visit all these nodes, and that's why the complexity will be O(n). And speaking about memory complexity, it will be OH, where H stands for the height of this tree. For example, since I'm going to apply the recursive approach, at each call seg it adds extra call seg, and that's why the memory will be increased by 1. and at each call stack it adds up on the whole call stack, and as we reach the base case, it will add the number equal to height. In this case, it will be 4 because 4 is the height of this tree. And this is all we need to know about this challenge, and this is the end of this solution. Let's jump into coding this challenge. Let's start from covering the base case. If depth is equal to 1, then we just create new node, and it will become the new the root of the whole tree, and the new node's left subtree will become the original root, and we just return this. Next, if depth is more than 1, that's not the case, and we need to traverse. For traversing, I'm gonna initialize new function. I'll call it traverse, and it will accept all these variables. Well, int depth, int, and additionally it will accept current depths, and it will be used to track the current depths. Here's a mistake. And let's write the base case. If root is equal to null, just return. If current depth is equal to depth minus 1, we create 2 new nodes with a value equal to val from the argument, and the same thing for left and right for the left and right subtrees. Apply the left subtree of the new node will become root's left subtree, and the root's left becomes new node, and the same will be applied for the right subtree. Right becomes root right, and the original root's right subtree will become new node. As soon as we apply all the steps, we just return, because here, as soon as we reach the base case, for example, this is our base case, we applied all the steps, we made this left subtree the left subtree of this new node, and we don't have to go deeper because there is no sense going deeper, because the depths will be more and there's nothing to do down here. That's why we just return. And we need to traverse. We need to call traverse twice. Traverse root for the left subtree until we reach the base case, and at each call we just increase the current depths, and we will do the same thing for root's right subtree. This is the end of our function, and we just need to call this function. Let's call it root depths, and for the current depths it will be by default 1 because the root starts at depths equal to 1, and we just return root. And this is the end of our function. Let's copy and paste here. I hope it will be accepted. Let's submit. Well, as you can see, our solution was accepted, and this is the end of this video. If you find it useful, please like and subscribe, and see you in the next video.